In this video, we will create a spawn system for enemy objects so that we can explore switch statement and enums in C#. So far, we have already discussed the if statement and how useful it is for checking a condition and performing some logic based on the outcome of this condition, so if true or false do different things. But what happens when we have more than just two paths to choose from? That is where switch statement is very useful. Switch statement uses the switch keyword and takes inside parentheses some value to compare. We have those curly brackets defining the scope of the switch statement, and inside it we have this case keyword, so each case is some comparison for this measurement to compare. So we are going to compare this measurement value to the less than 0 condition. So if this is less than 0, we are going to perform this line of code. And after that, we are going to use break keyword, which exits this switch statement. This is because we have found a solution to our query. So this is the solution this line of code should run, so we want to exit it. If this is not the line of code that we want to run, we go to the next case greater than 15, and so on, until we reach the default statement default, which defines what happens if none of those cases were useful, none of those conditions were met, so we go to the default and print or do something else. Okay, let's try using the switch statement to implement our enemy spawning logic in a new script that we will call enemy controller. In our project, you should see in the hierarchy that there is this enemy controller object, and if we expand it using this arrow, you should find that it has 4 child objects, and in the scene view you will see that there are those 4 yellow diamond shapes. Now if you do not see them, use the gizmo toggle in the top right corner of scene view to toggle those on, and here are the points that we want to use for spawning our enemies. The idea is that we want to spawn enemies in those corners so that they can walk towards our player. To add this logic to our game, we first need to create a new script. So let's go to our scripts folder in the projects tab, right click, create a new C# script, call it enemy controller. Again, scripts, we call them using capital letters for each separate word, and let's open this up. Great. At the top, inside the class scope, we are going to define some variables. Let's create a serialized field, and we can use enter to autocomplete and arrow to go to the right, and we are going to create private. And we are going to call game object with capital G and capital O. And you should have autocomplete for that as well. Let's call it underscore enemy prefab with capital P. And let's add semicolon. The game object type is a way to reference an object in Unity scene. So basically, if you wanted to reference an enemy controller object, not transform, not audio source that is here, but the object itself, we want to use game object reference. But the more powerful example of using it is using prefabs. So Unity prefabs system allows us to create, configure, and store game object complete with all its components as reusable assets. So in our project, we have those prefabs folder, and we have a player, enemy, and crab dead objects that we can reuse in our game. So that's what we are going to use this game object reference for. We are going to assign to it a prefab that we want to create, so our enemy. Great, now we are going to create a new value serialized field. And we are going to create private int, because we need to have a count of enemies. So underscore enemy count with capital C. And let's assign this to be 5 by default. We want to have 5 enemies at all time in our game. Lastly, we need to know where we want to spawn those enemies. We already know that transform object already stores those, so position, rotation, and other values related to the game object in the scene view. So in our script, instead of using the game object, we can instead create a serialized field. And we are going to create private transform. So this is transform reference, and let's create underscore spawn top with capital T and left. So those are the spawn points that I have shown you in the scene view. Let's add comma because we need to have 3 more. Underscore spawn top right, and another comma underscore spawn bottom, left with capital L, and we are going to move to the next line, underscore spawn, bottom, right. And those are the 4 spawn points that we want to use to spawn our enemy prefabs. Now let's go to our start method, because we know that we want to spawn 5 enemies. So how can we enumerate between 0 and 5, so the values, to spawn 5 enemies? In one of our previous videos, we have iterated over an array. A hint would be that we did it using something called a loop. Maybe pause the video and try typing this code on your own, and let's get back to it when we are done. Okay, I hope that you said for loop, because we need to type for, open parentheses, and we are going to type int I equals 0, and we are going to iterate over I less, so until I is less than enemy count. And we are going to use I++ as the third parameter of our for loop, open the curly brackets, and this is how we can iterate over values from 0 to 5, less than 5, so we are not going to take 5 into account. Great. Now what we need to do here is we are going to call spawn and enemy, and open and close parentheses, and I have made a typo, so let me fix that. Okay, let's right click on this, because we can use auto completion to create methods. So quick action, and we can select generate method spawn enemy. So it was right click, quick action, and generate method. And here is our method. We do not have to type it on our own. Inside the spawn enemy method, it has created for us throw new not implemented exception. We are not going to focus on exceptions in this series, so just delete that, and we are going to create here a vector 3, because we need to know where we should spawn our enemy. And we are going to call this spawn position with capital P equals, and we are going to create a new method select with capital S the random, so select random position, and open and close parentheses and add a semicolon. And again, what we can do is right click on this, quick action, and generate method, and here it is. But before we go to the new method, we are going to add a new line, and we're going to call debug dot log with capital L, and we are going to just log spawn position and finish it with a semicolon, because it will be a bit longer video until we can spawn actual enemy objects. So right now we are going to print it to our console. Let's slide down to the select random position method. Now in this method, we need to select one of those transforms that we have created at the top. So how do we do that? Well, we are going to delete the throw exception line of code, and we are going to create transform. So this is a type selected with capital T transform. And we are going to set it to be equal to null, because we do not know which one it will be. Now we have the error because we are not yet returning anything, so just by default we can return vector 3.0 so that we get rid of this error, but obviously this will not help us at all. So we need to now select one of those 4 transform objects to get their position. How do we do that? Well, we can call something called int, and we can select a random value, so random with capital V value. And we are going to set it to be equal to random with capital R dot range. And we are going to open parentheses, and we are going to type here 0, comma, 4. And this will be it, because 4 is the number of those transforms. So we are going to select those based on the indices 0, 1, 2, 3. Now we have an error, at least I have, because this tells me that random is ambiguous reference. The problem is that at the top I have now using system, because Visual Studio put it here because it thought that I want to use system library. But I want to delete that, because in the system library and in Unity engine library there is a class called random, and this is causing a collision. So by deleting the using system statement at the top, I have cleared the collision, and now I'm using Unity engine.random.range. And this method is provided by Unity to return a random float within maximum and minimum range. But we are going to call this to save it as an int, so int random value will be equal to random.range. And there is slightly different version to create int values. So basically 0, this will create either 0, 1, 2, 3. Because now if we hover over this method, we are going to returns a random value int within. Min inclusive and max is exclusive. So 4 will never be generated. And since this returns an integer value, it will be only 0, 1, 2, 3 because this is the range. So here is a problem that can be solved using a switch statement. How do we create 4 different paths that our code can take based on our random value? So back in our script, just above the return line, we are going to create a switch statement and we are going to open parentheses. Here we are going to type random value because this is our value that we need to compare. We're going to open curly brackets and we are going to type case and we are going to first type the condition. So what is the condition? Well, random value can be 0, right? And we are going to add colon and press enter to create a new line. And here we are going to define what we want to do. Well, selected transform will be equal to underscore and let's select the first one. First one was spawn top left, so we're going to type spawn. And if you are not seeing the auto-completion, just press Ctrl or Command spacebar, and it should give you the auto-completion based on what you have already typed. I want to select spawn top left and add semicolon, but we are missing something. Well, control cannot fall out of switch from final case label. What does it mean? Well, we are missing with the break keyword, because this will break from the switch statement back to this method, and this will call the return vector 3.0. But actually what we want to return is our selected transform. Well, actually we want to return vector 3, so this is underlined red. We can't really implicitly convert transform to vector 3. So we need to call on this selected transform.position. Remember that this is null, so if we call it if this is null, we are going to get an exception, we are going to get an error. So we need to add more of those cases. But have you noticed something? Well, our case has no curly brackets, and usually we saw that with the class, with the method, all of those had those curly brackets defining the scope or the code block. So with the switch statement or even if statement, we do not have to add those curly brackets if we only have one line of code. In case of our switch statement, it is a bit different, but let's go back to our code and let's see if we can add a code block to it. So the switch statement has its own code block, but the case has not. What is going on here? Well, actually, we can add curly brackets anywhere that we want, and this defines a scope that is separate, and inside what we define here, inside it, it will be unavailable for the code outside of it. So if we define int a equals 10, we are going to access a and set it to be 5, and we cannot really do that. Okay, so we can add to our case curly brackets, and we can use Ctrl X to cut this code and use Ctrl V to paste it here. Now this makes our code a bit more clear, so I like to use this version, but you can definitely not use those curly brackets. Okay, let's copy this case statement because I don't want to type it for 3 more times, so let's use Ctrl C, let's use Enter, Ctrl V, and do this 3 more times, so we have 4 case statements. And we are going to just change the condition to be 1, 2, and 3. And let's select the selected transform in the second case block, and we are going to change the top left to top right. And again, you can use Ctrl space to fill it in, or if we go down to the third case, so case 2, we're going to change the spawn bottom. And again, we can press Ctrl spacebar to see bottom left and right. I will use bottom left first, and then at the bottom, we're going to type spawn bottom, Ctrl space, and bottom right. And we have all those case statements filled with the correct data. Actually, we are not done yet because we do not have the default case. This will happen when none of those cases will be working. What I will do is just copy the code block from the first statement, so even if we do not have the correct value, we're going to still return something reasonable, so the spawn top left. And now we are going to return to our spawn enemy method as a vector 3, and we are going to debug.log it to our console. So let's test it. Let's save our script, Ctrl S, let's go back to Unity. Great. In the project tab in Unity, select the scripts folder, and we are going to drag the enemy controller script onto our enemy controller object in the hierarchy and drop it and select it. Now in the inspector you should already see the enemy controller script. Let's leave the enemy prefab for now. We have the enemy count as 5 and let's assign the spawn top, left, right and so on just as they are in the hierarchy. So let's just drag spawn point top 1 as the first one and so on until all of those are assigned to unique objects from our hierarchy. So just check that all of those are unique. And now if this is done, let's press play. Great. Now in the scene view nothing happens, or in the game view nothing happens, but in the console you should see those two lines were printed 2 and 3 times. If I uncheck collapse, you will see that this is 1, 2, 3, 4, 5, so the number of our enemies. And they were spawned in 2 spots, this one, and those should correspond to the positions of those spawn points here in the hierarchy. Okay, stop your project and let's go back to our enemy controller script. Now if we go back to our select random position, those curly brackets added a bit length to our statement, but besides that, we have those case 0, case 1, case 2. Now after some time, I may not be able to recognize what this was. Now I know this is random value, but what does it tell me? What is this random value about? I could give it a more explicit name, but it would be much better if I gave those cases something to go on so that I can know that this is for the spawn top left and not for some other transform that we have in our setup. So what we can do to make this a bit more readable? Well, enumeration type to the rescue. Enums are used to give meaningful names to some values, so that the example is enum seasons, and we have spring, summer, autumn and winter, and we can use those names in our code instead of typing 0, 1, 2, 3. So in our code, in our enemy controller class, let's slide down just before the last curly bracket. Let's add more space here and we are going to define public enum, and let's call this spawn with capital S, spawn, point with capital P, type with capital T. And let's open curly brackets. Now notice that we have defined it inside our class, but we could very well define it outside of our class as well. Now it doesn't really matter for this example. We are going to type here top with capital T, left. The naming convention for enums is usually to use the capital letter first, but you can also see top left with all caps. I like to use top left with capital T and capital L. Let's add comma, top right. Let's add comma, bottom left. Let's add comma and bottom right. And no comma here. Now what C# will actually do under the hood is give those values numbers. So 0, 1, 2, 3. So each of those names will have assigned integer value to it. Although we can actually assign our own values as well. But by default they will be starting from index 0 and they will increment by 1. So this is useful for us, because now having that, we can go up to our select random position method, and just below this int random value we can create spawn point type, so the type of our enum, spawn type using camel case equals, and we are going to convert our random value to our enum type. How do you do that? Well, we are going to type parentheses, and inside this we are going to type the name of our enum, spawn point type, close parentheses, and we are going to type random value. And what this line will do, it will convert those values based on those indices 0, 1, 2, 3 to our spawn type top left, top right, bottom left, and bottom right, because we explicitly told the C# compiler that we can do that by typing the name of our enum in between those parentheses. This is called casting or conversion of C# types, and we can do this implicitly by just giving some value and converting it without typing anything, or explicitly by typing, for example, double x equals 1234.7, so this is type of a floating point variable, and we can have int value, so 1, 2, 3, and we are going to convert this floating point value by just cutting away this decimal value. So we're going to end up with a equals with the inside the parentheses int x, we're going to get only the integer values, so 1234 without the 0.7, and this will be outputted inside this int a variable. So going back to our code, how can we use this now to make our code more readable? Well, we can type, instead of the random value in our switch statement, we can type spawn, type, and now we're going to see that we have some errors. We can't implicitly convert back from our int to our spawn point type. But what we can do is, inside our case, we're going to call our spawn with capital S, spawn point type, so the name of our enum, dot, and we can type top left. And as you can see, we can already read that this is for the case spawn point type top left, and we are going to now assign this spawn top left. And we can just copy this spawn point type with a dot, Ctrl C, and let's paste it inside the case 1, dot, and this was top right. Let's slide down, case 2, it was bottom, and we have bottom left, and the last one was for the bottom right. And now our switch statement is much more readable because we know that this case is for top left corner, this one is for top right, and this is the idea behind using enums with the switch statement. So here the point is that enums will make our code more readable, and we should use them if we have limited amount of options, like here we have only 4 corners, and this will probably not change for our map. So we can safely state them as enum as the name, and we can use those names in our code to make our code more clear for anybody that is reading it. Okay, let's save our code, let's go back to Unity and press play. Nothing has really changed. Obviously we have some different outputs inside the console because this is random, but basic idea is that our code works the same, but it is more readable. Okay, let's stop our game. In this video we have explored switch statements and enums, but we didn't have time to create our enemies and actually spawn them. So we are going to take care of it in the next video, and we are going to explore what are events in C#. See you in the next video.